Hey kids, so this is one of the two videos you should be watching in my absence on Monday, and we have seen this already, but I wanted to make sure you knew this because it's better than what I was able to make as a GIF. I'll show you that in a minute. But here is water, right? And water, if I go here, water is an oxygen and two hydrogens. That's what water is, right? H2O, so two hydrogens and one oxygen. And what's going on here is they are in the solid phase. So this is a solid, there's movement. We talked about that already. There's always movement except at absolute zero. And what we're going to do, and maybe I should just put that in Celsius. No, I'm not going to put that in Celsius. All right. So what we're going to do is we're going to heat that up. And what you need to know about the difference between molecules and formula units is as I heat that up, now it's liquid. And after liquid, it will become a gas. And we talked about this when we did this. The hydrogen and the oxygens are still together, right? We did not break any covalent bonds. We only broke the bonds in between the molecules, not the bonds within the molecules. So the hydrogens and the oxygen are still connected. It's just they're not connected to each other. Each molecule is not connected to each other. And that is what happens when you melt something. So when you go from solid to liquid to gas, you are not breaking the covalent bonds. You are not breaking the sharing electrons within the molecule. You are breaking what's in between those. And that goes over here. So let's get back here. So that's what we were doing the other day when we were trying to do when we were melting compounds and melting solids that could have been ionic or covalent. If it were covalent, like water, and this is a little GIF I made, and you can see the H's stay with the oxygen, right? You're just breaking down why they were stacked on top of each other. So you're just spreading out the molecules. You're not actually breaking covalent bonds. You're breaking whatever forces there are that's keeping the molecules together. Whereas when you break up an ionic compound with melting, now you're pulling away the positives from the negatives, and that is harder to do. So ionic bonds break down, and this will take more energy. To pull away a positive from a negative takes more energy than to just pull away something that is in a certain position and you're just moving and there isn't that much of a positive negative attraction between them, if that makes sense. And this is the difference between a formula unit, right? Here's a formula unit and here's a molecule. So the molecules, and do we talk about that besides here? Yeah, right here. Here we did. So formula unit, and you should have watched this. If you didn't watch this video, I'm annoyed. But a formula unit is just the smallest repeating thing that happens in an ionic lattice. And so if you're pulling these apart from other ones, you're pulling away positive and negative charges. Whereas here with molecules, the molecules are already sort of independent and you're just pulling them away from each other. You're not breaking these bonds within the molecules. And because of that, it doesn't take near as much energy to melt a covalently bonded compound versus an ionically bonded compound, because you're not pulling apart covalent bonds. You're just pulling apart bonds among the molecules. All right. Now, water is polar. So this oxygen here, if you look on that thing that we did, would be very red, and these hydrogens would be very blue. Oops. And that is because, we might as well, they're sharing electrons here, right? The oxygen and the hydrogen is sharing electrons. However, the hydrogen only has one to share. And if that hydrogen electron is going to spend all its time in between hydrogen and oxygen, and in fact, more toward oxygen because the electronegativity is so much higher. The electronegativity of oxygen is 3.5 to 3.8, and hydrogen is like 2.1. So that's a huge difference. This oxygen is going to very much have possession of these electrons where these hydrogens are not. So that forms this positive area here. Back up. That forms a positive area here with the hydrogens and a negative area here with the oxygen. So it looks like this. So that's basically a charged molecule, right? That's just like what ionic compounds are. You got a very strong charge on one side and the opposite charge on the other. That's just like what happens with sodium and chloride. So that's why when you try to dissolve a covalent compound, which has equal sharing of electrons, or at least somewhat equal sharing of electrons, there's no positive or negative thing for these waters to grab onto. Whereas if you try to put salt in there, now there is a positive or negative thing for things to hold on to. And that's why salty ionic things dissolve in water, right? Covalent bonds will stay together because there's no charge to grab onto. But because water is charged, it can grab onto all these charged pieces. And there's another thing here, which I just remembered I didn't load, but it's not like you guys have anything to do right now. So let's go to one of my famous things here. Hold on a second. DC dissolving NaCl. So last year's class said they saw this forever. All right, we need to get this woman quiet. All right, so here's NaCl, and look, so the waters can pull it apart. The negative oxygen can pull the positive um, sodium away, and the positive hydrogens can pull the negative chlorine. Negative oxygens can pull the positive sodium. Positive hydrogens can pull the negative chlorine, and it just keeps going on and on like that. And that's because water is charged. Because water is charged, it can surround a negative ion with positive hydrogen ends, and it can surround positive ions with the negative oxygen ends. And that is very important that you understand this, and why I will go over it when I get back. But please realize ionic compounds dissolve in water because water is charged. There is a charge distribution in a water molecule. There's a negative end and a positive end. And because of that, they will attract to the positive, negative parts of the ionic compounds and pull it apart. Covalent compounds don't have those charges. They're not as big a difference in electronegativity. They're sharing much more equally, and therefore there's nothing for the oxygens and hydrogens to grab onto, so they don't dissolve. And that's what we saw with one of our compounds, that it didn't dissolve at all. All right, last thing to do. This is going pretty well. Last thing to cover is the electricity, right? So water by itself has basically very little, if any, charge things in there, meaning absolute charge. This is a hard concept to get, but even though water has a charge separation in it, right? The oxygen is negative and the hydrogens are positive. They can't separate from each other. How about that? All right. They can't separate from each other. So therefore, they can't conduct electricity very well. If, however, you just had like salt and no water, which is here, now for the same reason, even though there are charged things in here, they can't separate from each other. So there's no electricity flowing. And I will show you that later when I get back. I meant to do it today, but I forgot. However, if you dissolve the salt in the water, now you do have charged things floating around the water, and they can move around and make electricity flow. So the fact that these positive and negative things are free to move about because they're dissolved in water is why the electricity can flow through a circuit in this situation. All right. That's about it. So in conclusion, you should be able to answer now everything I gave you on your lab. The state of matter at room temperature, ionic things, because they're all these positive, negative stuck things, they're going to want to stay solid. Covalent things, because they are not so much attracted to each other with positive, negative charges, will be anything. They could be solids, they could be liquids, they could be gases. Melting and boiling points, you've learned hopefully, that ionic compounds will have high melting and boiling points, right? Because you're pulling apart those positive and minus charges. Whereas covalent compounds, which keep their covalent bond after they've melted, they'll have low melting and boiling points because you're not taking away that major bond, that covalent bond. You're just taking away the bonds in between the molecules, or the forces in between the molecules. Now, solubility, will it dissolve in water? Ionic, which has a plus minus charge difference? Absolutely. Water being a charged particle can pull those apart, but covalent molecules cannot be pulled apart by water because there's no positive or negative end for the water to grab onto. And can they conduct electricity? Ionic things, absolutely. They will conduct it well. Covalent things, not so much, because there is no charge to run the current. Remember when we did John-Tra voltage, that current is a matter of charges running around, specifically negative charges. So I hope that's all good for you. I hope to get back there soon. And I was just looking for John-Tra voltage, but I can't find him. So I'm not going to do that. All right. I am available. So you watch this video, you watch the other video where I did the electricity test, and now you can even predict what will happen with the electricity test and answer the blue sheet. You can send me a remind if you have any questions. I should be able to answer those without internet. I can do that through just a cell phone. And I don't know what else to tell y'all. So enjoy. I will be around. I'll hope to come by to pick up your finished lab questions by the end of the day.